Hello, everyone. Thank you so much. I really appreciate your time. Thank you for being here. You are here for session WIN302. This is Microsoft SQL Server Migration Strategies. My name is Rodney Bazo, and I'm a Senior Solutions Architect with AWS. And I'm part of the specialized Microsoft architecture team. Part of my job is to work with customers to help them migrate their Microsoft workloads to AWS, but also make sure that any workload that they deploy in the cloud is well architected and follows best practices. Now, I'll tell you a little bit about how this session came about. So we visit customers often, maybe twice a week sometimes, and we've seen common questions come up. So we took a lot of those commonalities, encapsulated those things into a session, which we're here to cover. That's great. There's one additional thing that we want to make sure that we provide, which is we want to be able to showcase a success story. So we are going to have Al Smith join us. He's a Chief Technology Officer at iSIMS. He's going to tell us a little bit about what iSIMS does, and more importantly, he's going to tell us about their migration of on-premises databases for their clients to the AWS cloud. So I will focus on the techniques for getting your data, your on-premises data, to the cloud. And then, of course, we'll wrap up with iSIM's migration journey. Before I get into the actual meat and potatoes of the session, I do want to point out a few breakout sessions that I would recommend you attend. The first one is learn about 10 years of Windows and .NET innovation in AWS. So I'm actually wearing a 10 t-shirt, which is the 10 years that we've been in the cloud. That one is led by Sandy Carter. She owns Microsoft workloads on AWS, so I'd highly recommend attending that session. The other session that I think you'll find a lot of value in is simplifying Microsoft architectures with AWS services. Now, it's great that you can bring your Microsoft workloads to the cloud, but you'll really be able to take full advantage of the cloud if you integrate with additional AWS services. So that one will give you a little more insight into the other things that you can do with AWS. And also, you're here for SQL Server. I would recommend also attending the Design, Deploy, and Optimize Microsoft SQL Server on AWS. It's a continuation of what we're talking about here. And we also have a customer speaking, very, very important session I would highly recommend attending. Okay, so we are going to talk about a lot of things today. I wish I could go in depth into each one, but there's a lot to cover. So in order for me to cover everything within our time frame, I am going to take some artistic liberty in certain things. So for hardcore DBAs, forgive me now. But we'll cover pretty much the migration techniques for getting your data from on-prem to AWS. We'll give you some best practices on the things that you should do to make sure that your migration is successful. A lot of things that customers ask about, a lot of things that customers have issues with. So we'll go over that. We'll also review some hybrid architecture design patterns, which you can use to migrate your data to AWS. And then we'll go into the actual migration methods that you can use. Backup and restore, database migration service, always on availability groups, et cetera. And then we'll give you some guidance for SQL Server 2008, 2008 R2 workloads. If you have them on-prem, what should you do? How can you get them to the cloud? Those things. And then, of course, we'll finish up with iSIM's migration journey. Okay, so to level set the conversation, what I'm going to do is I'm going to review the options for getting your SQL Server workloads to AWS. So let's assume that you're a customer. You've got workloads on-prem, and you want to take those workloads to the cloud. You have two options for SQL Server. The first option is a self-managed option, which would be installing SQL Server on EC2. EC2 is short for Elastic Compute Cloud. To simplify that, it is our virtual machines. So you get a virtual machine, you install SQL the way that you need it based on your business requirements, the replication, high availability, disaster recovery, the way that you need it. The other approach is the managed approach, running SQL Server on Amazon RDS. RDS, it is the short for Relational Database Service. It is offered in multiple database engines, Oracle, MySQL, MariaDB, and of course SQL. And let me tell you about the differences between the two. When customers come to us and say, which path should I take, what we do is we recommend reviewing, considering RDS first. Why? Because RDS allows you to take a lot of those administration tasks that your team would ordinarily have to take on and move those to AWS. For example, we take care of all of the operating system patching, installing the database management system, the patching, backups, monitoring, etc. As a customer, then that leaves you to focus on your data. It leaves you to focus on your schema and making sure that your data is optimal so that you can provide the value that you need for your customers, compatibility, etc. Now, because this is a managed service, we do tend to put some guardrails around the service. For example, you don't have administrator access to the instance that is running SQL. You don't have access to the file system. You cannot RDP to that server running SQL. So that's one thing. And then the other thing is that certain things are configured in very specific ways. I'll talk about that on the next slide. But if for any reason the parameters that RDS lives within are not suited for your specific use case, then our recommendation is to go with EC2. EC2 gives you a lot of flexibility, a lot of control. You get access as an admin to the instance running SQL Server. You can configure the backups. You can configure your replication, clustering, any complex disaster recovery design that you require for your organization in the way that you see fit. And of course, because it is, you get a lot more flexibility and a lot more control, you also have more responsibility. So the things that you would have to do would be patching, backups, monitoring, high availability, scaling, etc. It's not bad because those are the things that you'd be doing on-prem anyway. So takeaway is things don't change with this method. As far as the different functionality, features that are available for these two platforms, we have a lot of support. SQL Server 2012 through 2017 on RDS. You can notice that 2008 is crossed out because we don't want customers deploying any 2008 deployments. EC2, you have full flexibility. You can pretty much do anything that you see fit. There are a few callouts that I want to make sure that you understand, especially in terms of identifying which path to take. The first one is the high availability. With RDS, any version other than SQL Server 2016 Enterprise Edition will use mirroring for high availability. With 2016 Enterprise Edition, you actually get always-on availability groups currently, and in the near future, we're going to be supporting additional versions and additions. So that's one thing. The other thing is the authentication. So we support both Windows and SQL authentication on RDS, but in order for you to use Windows authentication, there are some pretty hard prerequisites that you want to make sure you understand. This would be using managed Active Directory, so RDS has to join Active Directory, and then of course with domain trust, you can continue to use your on-premises credentials, but it's just something to consider. The other thing is the backups. The way RDS takes backups is at the storage level. So let's assume that you have 30 databases on that instance. When you take a snapshot, those 30 databases will be part of that snapshot. And if you do a restore, when you do the restore, those 30 databases will be restored. Now let's assume you only need one database. You can still do it. There are just additional steps for you to get to that database. And of course, you can also do point-in-time recovery with RDS. So things to consider. These are the two options. So the migration methods that we'll cover will focus on getting your data to these two options. Before we get into the actual techniques for getting your data to those two platforms, I want to review a few best practices that we tend to review with customers all the time. So we want to make sure that we do some assessment and planning so that your migration is successful. There's a lot of things that you need to make sure that you have correctly. You have to understand a lot of things. So first thing would be to inventory all of your SQL Server dependencies. What does that mean? You want to make sure that you know exactly which web servers are interfacing with your SQL Server. It might be in a DMZ. You want to make sure you know that. Maybe it's a reporting server running on the land somewhere, or maybe a business intelligence group outside of your intermediate group. You definitely want to know who these stakeholders are, who these entities are, so that when it comes time for you to migrate, you know exactly who's going to be impacted, and you can minimize the impact to these entities, to these users. Very, very important. So once you know the who, the what is interacting with your systems, you definitely want to know how they're doing it. Windows authentication, SQL authentication, knowing that will help you decide which path to take, RDS or EC2. Definitely important. Next is identify the functionality, the features that your application, whether it's in-house or whether it's COTS, custom off the shelf, you definitely want to make sure that you know which features are being used, because there may be an opportunity for you to reduce your licensing costs via changing the edition of SQL Server. Let's assume that you're using SQL Server Enterprise in an older version of SQL that is required by your application. That feature now in the new version of SQL is available in SQL Server Standard. If there's an opportunity to change that to reduce some of the licensing costs, we would highly recommend that you pursue that. Of course, the other thing would be your licensing options, right? Where can you take your licenses, for example? You can definitely bring your own license. Really depending on the licensing agreement that you have with Microsoft, the options may vary. So understanding that will certainly save you a lot of money. Of course, disaster recovery and high availability certainly are things that you have to know how you should configure your environment. For example, let's assume that you need a multi-region deployment for disaster recovery. That can't be done on RDS, so it's got to be on EC2. Things that you have to understand so that you know which path to take. Performance requirements is really, really important, especially if you want to show management, if you want to show your stakeholders that the migration was a success. What does that mean? It means that you should definitely baseline your existing environment so that you get the data points, so that you know after the migration, you improve performance by X amount, you increased availability by tenfold, et cetera. Definitely important to make sure that you have those data points to reference. And of course, along with that, you will uncover the performance requirements, capacity planning. So you want to make sure that those things are also cataloged so that when you select the path, you know exactly which way to take. I'll give you an example. So let's assume that you have 50 terabytes of SQL Server data that you want to bring to the cloud. Currently with RDS, 16 terabytes is the limit for the storage. So you have to go the EC2 route. Something definitely to consider to understand which path to take. Another one that is very, very important, one, to reduce migration time, and also to be able to save you money on storage costs, is retention policy. If you're able to leverage your retention policy, then we highly recommend that you do it. Let's assume that you have 10 years worth of data in your SQL Server environment, but your policy dictates for you to have five years. Perhaps you should archive those 5 years that you don't need to something like Amazon S3, which is our cloud object storage service that is secure, persistent, and also cost effective. That would, if you do it before the migration, that would reduce your migration time. If you do it afterwards, that could considerably save some money on performance costs. Storage costs. And then, of course, understanding the migration options, which is what we're going to talk about today. And then the next thing to do that is very, very important, especially if you're migrating SQL Server 2008 workloads, but also if you're using any of the techniques that I'm going to talk about today, is learning the database properties for each database that you're going to be migrating. Recovery model, compatibility level, very important. Recovery model, because many of the techniques that we'll talk about today require full recovery mode, which keeps track of the transactions in the transaction logs in a very specific way. So things like that you have to know well so that you can execute correctly when it comes to migration time. And then the last thing would be to acknowledge your internal capabilities. What does that mean? Let's assume that your team is very tenured. They have the expertise in-house, but maybe they don't have the time to execute a migration. If you need to leverage AWS professional services or maybe a partner to help you with the migration, it is certainly something that you should consider and pursue if it's appropriate. Okay, so we'll go right into the different migration methods. And I'm going to start by talking about the hybrid architecture. So to simplify it, hybrid architectures allow you to integrate on-premises resources to cloud resources. And why do we care with SQL Server? We can take data from on-premises to AWS using these hybrid architectures. There are 5 hybrid data integration hybrid architecture services that I've got here. We'll touch on each one. The first one is S3, which is, as I mentioned before, a simple storage service, cloud object storage. It is secure, cost-effective, persistent. Other one is AWS Storage Gateway. Storage Gateway is a cloud appliance, software appliance that you can deploy on premises. It supports VMware, and also it supports Hyper-V. So you can deploy it on premises. And as of recently, I think about a month ago, we also have a hardware appliance that you can purchase and provision in your environment. I will talk about how this fits into the picture. RDS we talked about. We'll go into detail as to what that means. Snowball is another device that you can use. It is a ruggedized device. It is portable. It's tamper-proof, secure. And I'll show you exactly how this fits into the picture as well. And then the last service that we'll talk about, it is the Database Migration Service. The name is pretty self-explanatory, so I'm not going to go into that. Okay, so the first approach that I'm going to showcase is using S3 as a transport for your database backups. Now, on the screen, I've got an architecture that has an on-premises environment running SQL Server. And then I've got my AWS account on the left-hand side. It's got one VPC in a particular region. Within that region, I've got multiple availability groups, or availability zones, sorry. Each availability zone is logical groups of data centers within the same region that are far enough to be in different power grids, different floodplains. So you've got that physical redundancy built in. Now, the way that this would work would be we would take a backup of your SQL Server databases on-prem on that server. From that server, you would upload those database files, database backup files to S3. And then from an EC2 instance that resides on the cloud, we would download those backup files and restore those backup files as you would on-prem. Of course, that would make your databases available in the cloud. This would allow you to power this 3-tier architecture that we've got here, which is great. Your application's up and running. But as I mentioned before, part of my job is also to make sure that your environment is following best practices. So to do that, we have to make sure that we are following the well-architected framework. That means we want to make sure your architecture is cost-effective, performant, resilient, and also secure. So if we overlay that framework to this design, we would definitely want to make sure that we have multiple components of each tier in different availability zones. So that way you have the physical redundancy built in. And then also, in terms of cost optimization, we can leverage a VPC endpoint for S3, which would allow us to keep all of the traffic to the S3 servers local within that VPC. So you don't have to accrue any network transfer costs going outside to the internet to get to S3. So we'll certainly save you a lot of money if you are transferring a lot of data. So this is great, simple, it works, anyone can do it, even if you're running SQL Server Developer on your machine, right? Or Express. But what if we want to make it a little more user-friendly for the DBAs on-prem? We can leverage a storage gateway. So this appliance will allow you to expose the cloud object storage that resides in S3 in multiple ways. One, you can use it as NFS shares, but with Windows, we can leverage SMBs, CIFS, network shares. Great thing about this setup is that you can actually join that appliance to your on-premises Active Directory domain. Now, this means that if your SQL Server and your appliance with the network share were on the same domain, you can take the backups directly to the network share. You don't have to put them locally and then upload them anywhere. And then Storage Gateway, one of the things that it does is that it is configured to use a bucket when you are deploying. And that bucket will contain all of the data that you put into that network share. There will be objects in S3, And then, of course, once they're inside of S3, same as before, you can download those backup files to EC2 and then restore them the way that you would on-prem or just traditionally. But if you're running RDS, you would actually execute a store procedure that would allow you to restore directly from S3 to RDS. How does that work? The first thing that we would have to do is we would have to create an IAM role. The IAM role grants the RDS service access to S3. And of course, you can specify the bucket, et cetera, so you can have some security constraints built around that. And then you would configure an option group. The option group makes this functionality available, but it also allows you to specify the bucket where all of your backup files will be either stored or restored from, or backup to, sorry. So we specify the bucket as part of the configuration, and then we execute the store procedure to back up directly from S3. Very, very useful. And it is heavily optimized. So if you have a lot of data that you want to restore to S3, this is one low risk way of doing it. We know that it works. We're using the native SQL Server functionality. And currently we support full backups, but in the near future we will be supporting additional backup methods also. There are some considerations if you are using S3 to transport your backup files. The first one is the put operation has a 5 gig limit for that particular operation, which means that if your backup file is larger than 5 gigs, you definitely want to upload in parallel. And you can optimize the upload in various different ways. You can do it via the CLI. You can do it using SDKs or S3 Sync, for example. You would have to do that on your own. I'm sorry? Oh, on the side. GB. Yeah. Yeah, so that's a different limit. So thank you for calling it out. So the 5 terabyte limit is actually the max size of an object in S3. Okay, so that's what it references. So that means that if you have a 15 terabyte backup file on-prem and you want to put that into S3, you would really have to break up that backup file into 3 files. So we've got an example on the screen that says, SQL, take a backup of AdventureWorks and put them into 3 files. And then you take those 3 files, put them into S3. Each one is under 5 gigs or 5 terabytes. You've got the 5 terabyte objects in S3, and then you can restore to SQL from there. If you're using Storage Gateway to transport the backups, then all of those optimizations, whether it's in parallel, compression, et cetera, it's done for you automatically. So you don't have to worry about it. Very, very user-friendly. But what if you had a lot of data? What would be the easiest and fastest way for you to get the data to AWS? You can leverage AWS Snowball. So this is that appliance that I talked about. This is exactly what it looks like. It's got a Kindle in front of it with all of your account details. The way that it works is that you would go to your AWS console. You would place an order. You get this device. The device supports up to 80 terabytes of storage. It's got a 10 gig Ethernet port. You connect the device to your network. You put all of the data that you want to migrate to the cloud on this device. You send it back to us. We get it. And anything that you put into the device will get placed into an S3 bucket. Now, you can use this for SQL Server, of course, but you can also use it for disaster recovery or any other full data center migration that you may need. Once in S3, you can follow the same approach as before. Download and restore to SQL Server and EC2, or execute the store procedure that I talked about to restore directly to RDS. Okay, so now we'll go into the native migration methods. This is probably the methods that you're familiar with. The first one is logshipping. So logshipping can be used for pretty much any version in addition of SQL Server. It's available there. The way that it would work is you would have your primary on-prem. You would configure a warm standby in the cloud. You would configure a synchronous replication between on-premises and the cloud. Once all of your data was replicated, you were confident that the data was there, you could execute a manual failover of your applications over to the cloud. So one simple way of doing it, I know there's a lot more to this, but for the interest of time, I'm just going to keep it at that. But then there's one more thing that we can do to this particular architecture is, of course, make sure that it's well architected. For that, we would want to make sure that we have redundancy in place. One call out, as I go through the various migration methods, the icon at the top tells you what service, what platform this is applicable for. So this one is for EC2. The next one is very similar to the previous one, with the exception that you would need SQL Server Enterprise to use this. Same approach, you would have your principal on-prem. You would create a warm standby in the cloud. You would replicate your data asynchronously. And same approach as before, whenever you are ready, you can execute a manual failover once all the data was in the cloud. These two approaches have been used pretty heavily, for years, so very, very mature. Again, you always want to make sure that your environment is well architected. If you're using SQL Server 2012 or newer, one approach that you can use would be an always-on availability group. Same as the two approaches, this approach can allow you to migrate your data either with no downtime or minimal downtime. The way that this would work is, let's assume that you have an always-on availability group on-prem that provides you high availability. So you've got your primary replica, your secondary replica, synchronously replicating the data, just in case you run into any issues on-prem. But then to migrate the actual data, what you would do is you would extend your failover cluster to the cloud. Now this would be temporary for doing a migration. You would create a replica, secondary replica in the cloud. The replication would be asynchronous in this case. And then same approach as before, when you were ready, you would execute the failover. This one is something newer with SQL Server 2016, something that many customers have been using to scale out their on-premises SQL Server environments. So let's assume that you have a read-write master database on-prem. You can use this approach to have reads in the cloud around the world. This is good. It's great. You can also use it to change the operating system that you're using for SQL Server. So let's say that you're using SQL Server running on Windows on-prem, but you want to switch to Linux in the cloud. This approach would allow you to do that. I would consider this an availability group of availability groups because you're using multiple. So you would have one on-prem that would be doing the high availability support for that service. And then you would configure what we'd call a forwarder in the cloud, which would take the data from your primary and then forward it to additional replicas in the cloud. So certainly helpful if you want to change the operating system in your environments. Now, the other approach that can be used with pretty much any version in addition of SQL Server is transactional replication. There's a lot to this. We can spend hours reviewing this, but I'm going to simplify it a lot just to give you an idea of how it works. So you would have your publisher. It would be your publisher database, which what you would have to do is you would take a snapshot of your schema, of the objects that you want to publish, put them into a network share, and then the distributor would keep track of the changes that you want to replicate, and then replicate the snapshot in each additional transaction in the order in which the transactions were processed. So if you want to maintain transactional integrity, this is the way that you would do it. Now, one great thing about this approach is that it's not only SQL Server that is supported as a source. You can also leverage it, for example, if you're taking data from Oracle to SQL Server in the cloud. And then, of course, the subscriber would be the SQL Server environment in the cloud, which would be taking the data from the on-premises. Now, one of the best practices here is to put the distributor in a separate SQL Server so that you can scale out the different tasks that you're executing. Especially important if you are transaction heavy, if you're doing a lot of updates, deletes, etc. Okay, so the next approach is an AWS native approach. It is the Database Migration Service, and it actually is comprised of two different components. The first one is the actual Database Migration Service, which will take your data from on-prem to the cloud. It can also take your data back to on-prem if you wanted. So let's assume that you have a development team on-prem, and you want to take some of the data from the production environment in the cloud, have them work with that sample data. You can also do that. And you can also go from, let's say, SQL Server to Redshift, for example, which is our data warehousing platform. It's got a lot of support. And then the other component is the schema conversion tool, which actually allows you to take the schema objects, such as indexes, store procedures, from your source to your target. Now, this is more important, especially if you're going the heterogeneous migration route, meaning if you're going from SQL Server to, let's say, Amazon Aurora. This would allow you to take those components in a more user-friendly way. Now, if you are going to be using the Database Migration Service, we recommend you always run the assessment report. This will take a look at everything that you want to migrate from the source to the target, and we'll call out anything that requires additional work. So the sample here is that we've got X number of things in green that will carry over without much effort. But if you get reds, then you know that you'll have to do some refactoring of the components. An example would be here. Down below in the center, on the left-hand side, we've got an index for an Oracle component. And we have on the right what it would be, what it would look like for MySQL. So definitely leverage this component. Even if you're going from SQL Server on-prem to RDS, you can execute the assessment report. You can understand exactly how much effort there's going to be into the migration. So very, very handy. And you can also leverage it to do ongoing replication for your environment. It supports 3 different modes. One is ongoing replication. You can do a full bulk load of all of your data one time. Or you can keep track of the changes and only execute the changes to carry over. It is required for you to enable the change data capture feature on the source, which means that you have to enable this at every table that you want to replicate. And if you allow us to configure the source for you, and we have enough privileges with the service account that you're using, we can actually enable this when you are configuring the database migration service. At a high level, how would it work? Let's assume that you've got a source and a target in the cloud. The source is on-prem. You would start a replication service. You would connect your source and your target. You would select the data that you want to carry over, that you want to replicate. You would let the database migration service load the data into the cloud. And then whenever you are ready for the cutover, you can execute your cutover. Very user-friendly. And many customers use this not only for migrations, but ongoing replications for reporting, for making sure that data is geographically dispersed for various business reasons. It's pretty heavily used. And as I mentioned before, you can use it for homogeneous migrations, and you can also use it for heterogeneous migrations. So homogeneous would be from SQL Server to SQL Server on EC2 or RDS, and heterogeneous, of course, let's say SQL Server to MySQL or SQL Server to Aurora. And of course, we also support other migrations, but this is just an example for SQL Server. Okay, so I've showed you different methods that you can use for taking your on-premises data to the cloud. Now, let's assume that you come to me today and ask me which particular method is right for me for my workload. I'm going to hate to say this, but I'm going to say it. It depends. It really depends on the version of SQL that you're using. It really depends on the edition of SQL that you're using. Do you need ongoing replication? Do you need to take not only the data, but also any schema objects, indices, whatever, to the cloud? So it really depends for your specific workload. This matrix hopefully will help you kind of understand the different implications for making up or coming up with a decision for which is the right approach. But if you ever need help on deciding, definitely talk to your account team, talk to your solutions architect, or reach out to my team, and we'll be happy to help you. We've got a group of people who can definitely help you find the right path. Okay, so now let's assume that you've got SQL Server 2008, 2008 R2 on-prem. What do we do? The end is coming near. July 2019, you must upgrade your database engine. What does that mean? It means that you can upgrade to 2012 through 2017. If you're using 2008 R2 and you want to go to 2017, there are some prereqs that are on the screen. Service packs have to be applied. One thing we always recommend is to make sure you understand the compatibility levels for your application. Why? Because this is what tells the database what code base to use. For example, if your application does not support anything other than SQL Server 2008, we recommend keeping that compatibility level to 100. And if you understand that your application supports a newer code base, then you can upgrade that compatibility level. But you have to understand what the implications are, what the risk is, and of course, you have to have documentation to say that the application supports this. And the new home for these databases could be both RDS or EC2. You can put them in both places. They both support the compatibility level 100, and it's something that you can certainly test before the migration. And the way in which you can take that data would be by using mirroring, Logshipping, Database Migration Service, and of course, backup and restore. Our old, reliable friends. Okay, so to summarize, I'm going to review a few things that we've talked about. The first one is definitely understand the SQL Server version and edition features that you're using. This will definitely dictate not only which path to take, RDS or EC2, but it'll also determine how much money you pay for your licensing. Definitely important. As I talked about before, authentication requirements. Do you need Windows authentication? Very important. Amount of data being migrated, connectivity from your on-premises environment to the cloud. Do you have direct connect? Do you have a VPN? You need to understand these things before you determine the right migration method. And of course, you have to understand the migration options for you to execute the migration. New home, I talked about before, EC2, RDS, those are the two options. And if you need help, definitely reach out. AWS Professional Services is there to help, but you can also find many partners that are local to you who can also assist. And then never forget, once the migration is completed, or even as you're planning for the migration, your architecture should follow the well-architected framework. And then the last thing to always keep in mind is that even though you complete a migration, that doesn't mean that that's the end. It should really be the start of your cloud journey. Why? Because you want to make sure that you optimize after the migration, integrating with other services. Perhaps you want to change the database engine. In order for you to provide meaningful services to your customers, you really want to take advantage of the full functionality that the cloud has to offer. And I think these are some of the things that Al will cover in his portion of the presentation. Thank you, and without further ado, Al, thank you so much.
Oh, thank you. This might come in handy. Thanks so much, Rodney. So appreciate everyone's time. I want to give you a little bit of an overview of our company, our application, our customer install base, the requirements and workload. I think what it'll help you do is understand how we made our set of decisions on the "it depends" question. There are clearly a lot of choices, and I don't know that there is a one right choice. I think as you go through this and look at it, you're going to try to decide what are your primary drivers and what are your secondary. So for those of you who might not be familiar with us, iCIMS is a recruiting software company in the talent acquisition space. Been around about 18 years. We have about 800 employees, about 4,000 customers, and our product is used from about 70 countries. We started out selling our products to SMB-sized companies, and over the last 10 years or so, we've been selling to large multinational global users who have companies all over the world hiring many classes of hiring, everything from white-collar to recruiting to hourly to gig to university, all very different. And those different behaviors of our customers, even though it's a SaaS application, they all run the same source code, the workloads look very different. The sizes of their databases and their transactionality are very different. And those were important things for us to consider. The other thing about our platform is we're heavily integrated through the API level. For anybody that does hiring or has been through a hiring, there's a lot of steps to hiring: background checks, assessment, all kinds of things that go on. So we have about 900 products that integrate to our core applications. And that was a requirement for us to think about what that workload was going to look like and how that changes the shape and the transactionality of our system. We think we have actually one of the biggest ecosystems there of products that integrate. And then we really pride ourselves on customer service. So this entire journey in migration had to go with no customer impact, or if there was going to be customer impact, very predictable and manageable to their business. Give you a sense of where we're hosting from, because our journey started before the database. It started actually at moving everything off of prem into hosting centers in the cloud to begin with in 2 steps. So we primarily host out of the US, primarily East Coast around Virginia, disaster recovery in Oregon region. We hosting out of Canada, primarily out of Toronto with recovery in Calgary. We have an EU footprint out of Frankfurt, Germany, recovery in Dublin. And increasingly we're getting pressure and focus around Asia Pac. Less about performance, more about compliance things to think about, although performance is increasingly there, and with regulatory compliance around citizenship and things like GDPR, increasingly needing to separate data for customers to help them with their compliance and requirements. A couple things that we were trying to look at in our journey. We started like most companies. We were hosting in physical data centers, and really providing a cloud experience to our customer with the SaaS application. But we were really limited by all the structure of how quickly we can adapt, change. We were growing rapidly, really struggling. We made a decision to go hybrid first, move everything except databases, firewalls, routers, and switches, move all the rest of the application, basically app servers, utility services, and processing, into a cloud deployment. We knew that the time we were doing this, which is now at this point, I guess almost 3 years ago, that was also kind of the right cultural thing for our customers. Not all of our customers were comfortable yet thinking about their databases in a cloud structure. As you might imagine, with hiring people, you have a lot of sensitive PII and SPI data and information. It's just something that's a heightened awareness. And then there's compliance and regulatory requirements. So we decided to do it as a 2-step. One of the things we've just completed, or just about completed, is moving to a pure cloud deployment. There's a lot of reasons that are driving me to do that. Cost isn't really the primary driver. It's agility and nimbleness to keep moving forward quickly as our business is growing rapidly. And then really moving to model-based with autonomic changes. And when you look at things like RDS and other services that Amazon brings to you, your ability to do things with less people at higher scale with lower error rates becomes a really strategic differentiator in how we service our customers and give them a great experience. So what were our business drivers? How do you figure out which of those great choices that Rodney gave you are going to work? Well, our managed service provider couldn't support our growing infrastructure. We wanted to reduce the time to expand our capacity. We were constantly growing, and the time to add new servers and expand meant that we were buying in big chunks with a lot of things sitting idle in a classic hardware step function of a lot of idle time till we grew into it, and then another big step. Our customer experience was struggling. The infrastructure was a bit brittle, and our providers really weren't doing a great job keeping up with all the changes. As you might imagine, our class of data has a lot of people who want to get their hands on that data, so security requirements were pretty high. One of the things that I think that we were really focused on also is the maintenance windows that we had were fairly long. And so how do we address moving the databases along with the whole infrastructure into a cloud infrastructure and give people a lower maintenance window? And then we had little experience at the time we were doing this with production cloud deployments. Those were all some of the criteria that we were trying to deal with. So we decided to do this in 2 phases. The first phase, as we went through, was going to that hybrid data center approach for the app servers. We wanted to make sure we could build our skills. We wanted to make sure that we adopted a fail-fast methodology of trying things. Research only takes you to so many points when you have a lot of moving variables. One of the really great decisions that Rodney covered, I think ended up being a really great risk reduction for us, was using Logship to replicate our databases. First, from one data center provider to another. That was our first move, get to a better provider in our hybrid model. And then recently, when we made the move out of physical data centers into cloud, Logship for us just worked well. We found that it allowed us to do a lot of things within a maintenance window and build confidence that everything was ready for the cutover. And it really wasn't a migration at that point. It was cut down, repoint the app servers, and bring it back up. And then we migrated, ended up taking 3,500 customers in 90 days. That was pretty amazing. Our first move, when we moved from one physical data center provider for the databases to another, we also decided to get off of 2008 R2 and move on to SQL 2014. We felt that that was the right time since we were having to performance test, reconfigure, re-examine our security models. All those things were going to change anyhow. Let's go make that move. And we found that we were doing pretty well in automating and managing the application server layer in AWS. Now kind of move faster here to this part of it. How do we move the second part of taking the databases out of the physical data center? We know that we wanted to accomplish a number of things from a business point of view. A better RTO and RPO. We decided to go to SQL 2016 to take advantage of availability groups. That was going to help our application, help our SLA management, and also do that without having to really have a lot of extra people on our staff to try and go do that. We also wanted to really improve our security models, and we're in the middle of doing a blue-green kind of maintenance model. And doing that, we felt that the whole environment needed to be cloud-based to really synchronize the way we wanted to go. We also wanted to take advantage of a lot of the high availability infrastructure that Amazon's already built, the availability zones, the regions. Those things just add a lot of, I'd say, assurance and comfort that it's less that we have to engineer ourselves. And I think when you just start looking at this, you end up doing a lot less complex engineering the more that you take advantage of the services that they have. We originally started the journey looking at moving to RDS. Part of that is because a lot of our customers' databases, which are single tenant at the customer level, were pretty small, around 10 gigabytes or left, and we felt that an RDS deployment would work pretty well. We did end up making a change initially for the migration to go to EC2, and I'll take you how we went there. So I borrowed Rodney's slide here. I wanted to move for RDS for all the reasons of taking advantage of AWS managing a lot of that environment. And that's, by the way, still in the roadmap of where we want to go. For a lot of our smaller workloads, we feel that the advantage of having them manage the patching and all the other work that goes on there, that will be an advantage. But we did run into some problems for our application at the time we were doing this. So a couple of those limits that were in place. By the way, most of these have left, and I haven't seen a preview on tomorrow's announcements, but I imagine what's left will also disappear. But we were running our customers' databases at a lot higher density than RDS ran. For smaller customers, we were running like 150 database containers on a cluster of servers back on SQL 2014. We were limited to 40 containers, and that would have been a lot more RDS instances that we would have to manage and drive some cost up. We also had built a lot of homegrown utilities over 18 years on how we did individual database restore, how we provisioned a brand new customer. And the fact that at the time that the family GUID was the same for all the database containers on the RDS node, that caused problems for us with the software tools we had built. It's something that's been removed as a restriction, but it was something that was in our way. We also have reasons to restore other than disaster recovery. Sometimes we have customers that go through drastic business change, or we have a need to bring them back to a point in time, and being able to do that in a very easy way. Again, we had built homegrown scripting and utilities over the years, and I didn't really have the bandwidth to have people update that scripting, or more importantly, replace it and eliminate it. And that just proved to be a piece of work that we thought about having outside help to get us there. But as we were going along here, we're kind of going down the death of a thousand cuts of added time and complexity. When we started the journey, time was our friend, but every time we ran into a problem, we got closer and closer to the point where time wasn't our friend. I think at the end of the day, we became the bottleneck. And then finally, one of the things is it turned out that to take our licenses, we own quite a few SQL Server cores. We were in a financing plan with Microsoft, which had system assurance or software assurance as part of it. To make it portable, I had to then add additional system assurance, which I've had to do. I would like to go to RDS and eliminate licensing my own cores because it is pretty dynamic for me. But at the time, this was also something I wasn't planning on. So at the end of the day, we started with EC2. We also wanted to really get to an all-cloud infrastructure with some urgency. We have a lot of changes going on with our business. That kind of baseline for everything being in that position just gave us a lot more options to grow forward. This is important. The move to EC2 didn't require us to spend time doing material work on rewriting our homegrown tools or automations or reskilling in a heavy way. We did some. It's not zero, and then when I say we, I don't mean me. I mean my team, some of which are here, did the real work. As I say, I play one on TV. But I think at the end of the day, we found that the comfort level of being able to kind of make the decision and go was real important. So we started here. In our deployment evolution, we kind of went, like I said, from a hybrid model to a full cloud deployment. I'm going to run a little faster to some of the things I think that you're probably caring about. I heard Rodney emphasize the planning. Let me re-emphasize it. You probably have different kinds of workloads with different kinds of SLAs on it for different kinds of users. I think those are the big drivers for you on trying to decide which migration path to go down. Cataloging the dependencies ended up being critical for us. Identifying which SQL Server features we were using. Turns out, we weren't heavily using stored procedures. Our application generates a lot of SQL. We did care about the cardinality of indexes and how well they performed at high volume. Our application tends to be heavily read-oriented. Somewhere around 90% of all the access is reads. And so those are all things that we tried to look at what the shape would be in those deployments. Understanding the server and application requirements, particularly around IOPS. When we started the journey, it was a fairly distinct line on the storage about provisioning IOPS versus PIOPS, and the cost differences were pretty material. Now that's actually a lot changed, and you can get the dynamic bursting. We found that worked pretty well as we started the performance test for our biggest customers. We wanted a solid authentication plan. Windows authentication versus SQL was a really important set of decisions. Putting all of our database properties and knowing what we needed to do. Again, know your data and the quantity of your data and how much you're moving when. I think those are really pretty important, critical factors. And thinking about your retention policy. We ended up, when we made the move of getting rid of tape backups and getting rid of Iron Hill storage for contractual purposes and going into S3 with rapid move into Glacier. For contractual compliance, and that's worked out pretty well for us. It also opens up doors if we ever needed it around multi-region disaster recovery using S3 replication. As it turned out, we haven't had to need it going to availability groups, but at earlier versions of SQL Server, that was another option for us that we took advantage of, just giving us peace of mind. As you start this journey, we kind of overlayered our disaster recovery and backup, and as we got more and more skilled, more and more automated, we started peeling back to the things that we were comfortable with. But it's good to have options. Things can go wrong. Going through your migration options are important. This is an eye chart for you, but I think there's a couple points on this kind of this project plan. We were constantly rolling out new software to our customers. As a SaaS vendor, we roll out weekly updates and monthly updates of major new features. And that all had to happen while all this was going on. So you'll notice pauses in here when we had a major product release. We actually put a pause to the migration at a certain point. We didn't want the complexity of moving somebody from a on-prem deployment to cloud to be confused with, hey, we had a major new release going out and database schema updates supporting that and not being able to get to root cause if there was a problem. So we migrated a number of customers up to the point where we were going to roll out new release, put a pause to the migration from physical to cloud, finished on with that migration and kind of went into a trailing model where we would move customers to the new version of software, make sure things were stable, and then move them into the cloud a week or two later so that we can easily diagnose and do root cause. That was a real important decision, and it worked really, really well. The risk of doing too many things at the same time mean that if things do go wrong, your ability to react fast enough is really compromised. Some things that you might care a lot about. We did a fair amount of testing in trying to understand the performance characteristics, the shape characteristics. A couple things that we were pleasantly surprised on. We have things called desktop widgets as part of our application. People can configure anything. Those tend to be a big overhead performance suck. They were performing better. Generally, logins were faster. Our API testing was faster. All to the good. I don't know that we were expecting material performance improvements, but we got the benefit of that. And then we started putting heavy load on, looking like real load work sets. And again, all of them were material improvements that in an area that were real important to us. And this was important for some of our largest customers, where they're running maybe 12, 15,000 concurrent users a day, with a 4 terabyte database. Those kinds of workload differences on what they were doing were real important. And then changes in Failfast. There were changes that had to be made to our plan. And so how do you decide how much to do the research before you go into it? Shared disk failover, clustered instances to availability groups. We decided to let's try availability groups in a small pocket. Felt comfortable with them, make the move over. That was an important decision for us. Upgrading the database engine from 14 to 16 to take advantage of the better availability groups in 16, and also trying to keep our application infrastructure more current so that we can really take advantage of and exploit and not build a lot of technical debt that we had allowed to accumulate. We had one instance. We took advantage of the compatibility mode that Rodney had, where cardinality on the kinds of SQL hits and API hits, we were worried about the cardinality of the performance at SQL 2014. We used 2008 for a while. Now we've finally moved them to 16. But that helped us not have to spend a whole lot of time over-engineering a lot of SQL changes on what was going on. So it's something that's available to you, and it's a good tool, and it worked generally pretty well. We also upgraded our operating system at the same time. Our journey's not over there. I do want to get to Linux on most of this. I think it's the right way to go. And there were some technical settings that we felt that we could take advantage of that helped either overall performance, footprint size, or deployment. I think at the end of the day, a lot of these thresholds actually allowed us to better optimize cases where we were doing a lot of, over the years, utilities outside the database structure to kind of keep things healthy. And by being able to take advantage of some of these configuration changes, the environments were healthier on their own. And that was a real important outcome for us as well. Resizing TempDB was a big one. Some of our log activity, volume of activity, API imports, particularly when customers are doing major migrations of their own, migrating from other applications in, TempDB is always a difficult management for us. And so we really got some benefits around that. While we were making this journey, AWS made some improvements that really made a difference in the journey for us. The number of exposed cores, it allowed us to size on bigger servers, but not pay the license fee for every core on that server. So it let us do things with flexibility. If we needed to upscale somebody in an unknown, we could go for those cores or pack more densely without having to pay the core price based on the size of the machine alone. So it gives you a much finer grained control on your SQL Server licensing. And I think that was a really important capability. Modifying EBS volumes, being able to handle our quick growing customers or rapidly changing environments without having to detach and reattach and having downtime around that, big deal. This made a big difference for us. And really it keeps a small amount of free space on the systems and dynamically grow it as we need it. And then the ability to add and remove PI ops. This was, I think, a big winner and a big cost savings. Remember I said those different customers have different shapes and performance characteristics. They also have different life cycles. When they're first implementing our products, they may be migrating hundreds of millions of records into our systems and trying to get those things in the shortest time window. So running PI ops for short periods of time are great, and then be able to drop to a more cost-effective IOPS kind of mode really makes a difference. And I think, again, this is on an ongoing basis really important to us to keep costs where it needs to be and still deliver a great experience for our customers. And then I can't underestimate the partnership with Amazon. We are an EDP partner, and we do have an enterprise service agreement. We have 2 TAMs that do a great job with us, and an architect who really worked on making sure we were architected properly. That partnership really proved be a time saver and a risk reduction. And I think rather than trying to say, hey, I think we started kind of thinking, let's just learn it on our own so we really know it. I think we very quickly realized that what you know is moving so fast that you may not catch up. That you're really much better off partnering with Amazon right up front because as you're making these decisions, it's moving out from under you. And some of those changes are so good that if you're not keeping up with it, you might actually spend a lot more money, carry a lot more risk than you need to. And so it was a great experience for us, and it's a continuing relationship for us that we really value. And then the takeaways, and there was an over-under bet on how close I could come to time on this, by the way. And just for the record, I do have about 10 seconds. So the takeaways for us: evaluate your homegrown tools. I think that caught us off guard. I don't think we realized how much we had built up over the years and how much they were going to be a bottleneck to making changes for ourselves. Working with Amazon to identify cost reductions. We came to them and said, here's cost that we don't think makes sense for us. Can you help us? And they really did in a variety of ways and continue to. Trial often and fail fast. And the big thing, when you fail fast, make sure you document what you learned from what you fail fast on. I think people talk about fail fast and don't realize the value of that is the learning, not getting it done. It's the learning that you're going to do at scale. So make sure you really capture what you learned out of that fail fast. In our case, we started with smaller databases, lower risk. You could throw hardware at it to kill it, and then worked our way up to the larger ones. And we scaled to bigger instances. The one thing I love is, when you're unsure and you don't have time to test it to the nines, let's provision and over provision, watch it, scale back down to what the systems are really telling us. And being able to do all that dynamically, been huge. Short spikes and over provisioning really hasn't been a problem. And then automate the creation of new instances for customer provisioning. Why is that important? Well, if you get that right, it may also be a critical part of your disaster recovery plan, because that provisioning and scaling out and dynamically putting things out there might be part of what you do in an automated way if the normal systems don't really handle the dynamic failovers that you're looking to do. So the end result of this is we're now in a much better position to fully use our native cloud services across the board. And that was really one of our big targets on why we started the migration. As you're all learning, I'm sure here, is the rate of change and innovation that's coming fast and furious. If you're not in the mode to take advantage of it, it's almost money lost, depending on how you look at your other costs of doing it. So that's it, and thank you for your time.